Welcome to video 17 on accuracy, precision, and percent error. This video is going to help you understand the difference between accuracy and precision. Then also we're going to learn how to calculate the percent error and understand what this value means when you consider the data. So the key vocab terms we'll be looking at: accuracy, precision, and percent error. Accuracy. When you see the word accuracy, think of the word closeness. Another word you can think of is the word actual. So every measurement out there has a correct value, has a value that actually exists somewhere in the world that if you had the perfect equipment, you would get that number every single time. So in a lab, when we do experiments and we come up with a number, or when we take a measurement of something, the closeness of our measurement to the correct value is considered the accuracy. So imagine I am measuring out a pencil that is 6 inches long. If that pencil is exactly 6.0000 inches long, then when I took a measurement, anytime I got a number close to the number 6, my measurement would be accurate. If I took a measurement and it came out to 7 or 5, we would probably consider that inaccurate. So the idea of accuracy is the closeness to the correct value. So the word I want you to look for when you hear accuracy is think of the word correct. Accuracy is the correctness. Another word we use is precision. Precision is not necessarily the closeness to the correct value, it is the closeness of measurements together. Let me say that again. Precision is the closest of measurements together. So when you think of the word accuracy, think of correctness. When you think of precision, think of together. So here is a bullseye. Obviously, the goal of the bullseye is to hit, or the target is to hit the bullseye in the middle. This person had 4 chances. Their 4 chances were precise. They were consistent. They were together. But they were not very accurate because this obviously was the target. This was the correct measurement they were looking for. So go back to the pencil illustration. If my pencil is 6 inches long, but I took 5 measurements and they all ended up around 5.5, 5.4, 5.5, 5.4, 5.3, those measurements would be considered precise, but not necessarily that accurate. Here's a table to kind of show you how they would compare. So consider the first target. This target would consider to have low precision and low accuracy. Why is there low accuracy? Because only one of the 7 shots hit where you were trying to get to, hit the actual point of the game. Low precision was also because they were scattered everywhere. They were not together. So again, accuracy is about correctness. Precision is about together. This bullseye, we see we have low accuracy because, again, we missed the correctness. We missed what the actual attempt should have been or whether we should have ended up with the results. The precision, however, was high because there's a togetherness of the readings or the attempts. Here we could call this high accuracy because, again, we are pretty close. 4 of the 7 opportunities were pretty close to the correct value, but low precision because they were still spread out. The distance from here to here is pretty far considering the distance from here to here. And of course, this is what we strive for in the lab. This is what we strive for with the high-end equipment we use to take measurements, is we strive for high accuracy and high precision, where all of our values are pretty close together. I mean, we had good lab practices, and the value we came up with was pretty close to the correct or accepted value for that measurement. So again, keep it simple. Whenever you use the term accurate, you're talking about a measurement that is correct. When you're talking about the word precise or precision, you're talking about a group of measurements that are consistent or together. So now we're going to look at this equation, percent error. Percent error is just a way for us to determine that when we came up with a number in the lab, how close, how accurate was the value we came up in our experiment to what the actual number is. So out there in the world, when you when you consider all the scientists and all the work that's been done before you in chemistry, there's a lot of research and a lot of things published on actual answers, the actual density of something, or the actual mass of an atom. And so when we look at the experimental value that we may calculate in the lab, we can go back and compare that with the actual value and come up with our percent error. So this is a pretty simple math equation. You're simply going to subtract and then divide. So let's take a look at a value or a problem. A student measures the mass and the volume of a substance and calculates the density to be 3.40 grams per milliliter. The correct, again, the accurate, so we're looking for the word correct or actual. That tells me we're talking about accuracy here. The correct or actual value is 3.60 grams per milliliter. What is the percent error of the experiment? Or in other words, how far off was the student from getting the correct value? Well, we would use our equation here, and this is an equation you should become familiar with. And when we go to plug this in, we would see that the value that we got in our experiment would go first. Then we would subtract that by the actual value or the correct value. And then we would divide by the actual value again, multiply by 100, and that would be our percent error. So let's do one more problem together, and I'm going to show you how you do this using a calculator and how you would set this up from scratch. So again, consider the problem that was given to you on the screen. Here it says, what is the percent error for a mass measurement of 17.7 grams, given the correct value is 19.8 grams? So obviously, we're just going to do the equation we just looked at, which is our experimental minus our actual, divide by actual, times it by 100, and hit the equal sign. So to set up this problem, I would take whatever the problem gave me as experimental. So here, percent error for this measurement, so that's going to be my 17.7 grams is going to be my experimental. I subtract that from 19.8 grams. Notice I am keeping the units. Then I would divide again by the actual, so that's 19.8 grams times by 100, and we'll see what we get. As I put this number in my calculator, I'm simply going to put 17.7. You have to do the subtraction first due to the orders of operation. Subtract it by 19.8. I'm given a 2.1. I will divide that now by 19.8 to give me 0.0. I times that again by 100. And it's going to give me a negative 10.6% error. Why did I go to 10.6? Because when I subtracted these two numbers, I was precise to the 10th value. And then when I divided, we would have saw that we had 3 sig figs here. So there actually would have been 2 sig figs in our answer. But for these kind of problems, you'll see that the math and the sig figs gets rough. So I'll be pretty lenient on these sig figs. Plus, we're still working on those. So for this value, we'll call this 10.6% error. So what does that mean? Why did I get a negative number? Well, a negative number is what you're going to get when your experimental is less than your actual. Look up here again. My experimental was less than my actual, so I'll get a percent. If this was reversed, if this was 20.7, if what I got in experiment was bigger than what I should have got in all reality, then my percent error will be positive. So a quick general concept here is if something is negative, that means your experimental was less than the correct number. And if your value of the percent error was positive, that means your experimental was more than the true or accepted value. Just a quick general idea to see from the math. Again, I hope this video has helped you understand the concepts of precision and accuracy, and how we can use this equation, percent error, to determine the accuracy of any experiment that we do and understand how accurate we were in our lab. Thank you.